Okay, good morning, everybody. Thank you very much for coming to this talk. So we're going to continue in line with the services oriented architectures, like we were talking about microservices, and I'm going to talk also about another library for microservices. But I wanted to start to understand what is a service-oriented architecture, because it's a very old term. Do you know how old is this term, this concept? 20 years. That's perfect. Yeah, exact answer. That was fast. Yes, at least 20 years old. So it's an old concept. It's a bit has become a bit ambiguous. So I wanted to clarify a bit. Like for this context, for this talk, I wanted to put here the definition from Martin Fowler. Microservices is an approach to developing a single application as a suite of small services, each running its own process and communicating with lively mechanisms. It's a bit different from SOA, but I think it's what most aligns with the library I'm going to talk about. Microservices is a younger concept. Yeah, I think that fits better. So for this, now that we're on the same page about services, what is PySOA? So PySOA is a general purpose library for writing microservices. It's very light. It has only, it's not very opinionated. It's general purpose. It provides both a client and a server. And it has a RPC communication style, so making remote procedure calls. And it uses Redis as a message broker. So it's an agnostic system, but today the only implementation available is Redis. So you can see here a very little example of you have a client, you have a server, and it's going to communicate through Redis. Why this library? So how was this library born? So this was born at Eventbrite. Eventbrite started, created this library. And I'm going to explain a little of the context of why this library was born. So Eventbrite is old, and it started with a monolith, as most of the systems today. Later, 6 years later, we started breaking up the monolith into multiple services. But we created an in-house framework for that. There wasn't many tools available at that time, and they created this SOA framework ad hoc for their infrastructure. But it has performance issues. It has design problems. And then with all the knowledge they already had, they tried to create a new library that fits in their architecture with the context they had. So we had Redis, we decided to use Redis. We wanted to implement an interface similar to the interface we had in our current services, so the migration was not very painful. And up to date, we are serving a lot of traffic. Yeah. So how does it work? So the focus of this talk is for talking about how it works under the hood. But first, I need to explain some of the concepts that we had in this library. First, we have servers. The servers of PySOA are composed by a set of action handlers. It could be the views from Django, for example. It's a nice similarity. The clients are going to send requests, and these requests are composed by jobs. And a job is a list of actions we want to get response from. These actions have an action name and the arguments of this call, which is a message, or the body as well. You can call it message body. These messages are Python dicts. That's it. Okay, and this is a message pack for serialization, but you can use whatever you want. It's also agnostic on this part. This is an example of the client and the server sending in an RPC style, a remote procedure call style. It's sending the name of the action and the arguments we want to pass. And you can see it's here. Yeah, it's a dictionary. Okay, this is an example, and it's sending multiple messages. But the server also sends the response with the same mechanism. So it's sending also Python dict, and we're going to see that they use the same system for exchanging the messages. So we are going to use Redis as a message broker, which in a symmetric way. And it's based on basically in managing lists with Redis. So we have these two methods in Redis, which are rpus and lpop. This is for managing lists in Redis, and we use it as a queue for the messages in PySOA. You can see rpus is going to push values to the right of the list, and lpop is going to get those elements out of the list from the left. Okay. But on top of this, there is another command in Celery, which is the. Oh, sorry, Okay, sorry. I wanted to explain, to give an example of these commands, how they work. So this is a Redis CLI. I'm sorry the screen is small. I don't know if you can see it, but basically what I'm going to do is I'm going to prepare my snacks for today with those two commands. The idea is I'm going to make a peanut butter sandwich. You can see here I'm pushing a few values, the rpus to the key, and the value I wanted to push. This is it returns the length of the array. Okay, so now I have a list with those toppings, and with lpop I can pop the messages out of the key. The key here is merienda as well. Here you can see they got out in the same order they got into the list here, and in the end the list is empty. So on top of this we have blpop. Blpop is like lpop but blocking. So it means that it's going to wait for messages until it timeouts, and we can give a specific timeout. You can see here the syntax. We send blpop with the key. In the previous case, for example, it will be merienda, and we set the timeout. So I'm going to show another example of this using this command. Here I'm going to do blpop on merienda, and this 5 is the timeout. So it's going, if in 5 seconds there is no value pushed into the list, it's going to timeout. Okay, there we go. Timeout about 5 seconds. Now I'm going to do the same, but I'm going to wait 10 seconds. So I have time to push some value in this other cell on the right, rpus, merienda, and send this value. So you can see here, I got the message out. The banana. As soon as I push the message here, the command on the left that was waiting for a message got the value and returned it. Okay. Okay. Now, so how do we use this in PySOA? I'm going to try to explain how PySOA uses this with another example. On the right, we have a client. On the left, we have a server. Let's say the server is the kitchen, for example. We are in a bar. This is the kitchen. And the client is going to be the barman and is going to ask for food to the kitchen. In the middle, we're going to have the Redis server as a broker. And we are going to set here a key in the server for and a list to send the messages. Okay. Let's say the kitchen can give paella and coffee. Okay, and we are going to and the server, as soon as it's started, starts listening, triggering a blpop. So it gets a blpop and it's going to be waiting for any messages on this list every 5 seconds by default. So it's basically polling for messages. Then the barman is going to send a message, push, saying the action that wants to call to. In this case, we're going to order a paella with no chorizo, and this and this is the repli 2 is going to tell an address in Redis, a key in Redis, where we want to get the answer. Okay, I simplified here a lot, but this is handled by PySOA. PySOA uses a different algorithm to decide the number, the address. But here I simplified with 1, 2, 3. Okay. So as the kitchen is listening, gets the message reloaded and it starts working on the paella. Okay. While it's working, right after the message is sent, the client is going to use the very same mechanism the server was using, BLPOP, to listen for an answer in the other address. In the address that the client already said where wants the message to go, the response to go, okay? So after some time, the server is working, and then we finally have the paella, and it's going to use the same mechanism to push the message to the response address with another Python dict sending the dish. And as soon as it's sent, as the client is listening, it's going to get the message. And that's how the barman gets the paella. And then again, the kitchen starts listening again, and it's going to get any messages that could have been queued there in the meantime, for example. Because think that we may have more barmans. Then more barmans have been pushing values to the list, and then if you have one worker, you usually have more, but in this case, say you have one worker, you will get the messages from that are already queued there. Okay, some code. Let's see some of the code. It's very, I've set a very simple server and client. Here, as I say, the servers are composed by multiple actions. Here I'm defining just one action, which is the square action. It's going to take a number from the body and square it and return the result as a dict. See, this is it's going to extend the action class, and you define the run method, which gets a request. Very common syntaxes for okay. And returns the square. So, and in the server, we are going to give the server a name, and we are going to map a system name to this, like a path or a name for this action. And then we start a loop working for that. What about the client? The client just needs to set some settings for communicating with the server. You have to tell the client where is Redis, what are the parameters for Redis. Usually that's enough. And then you just call the action like this. You get a client, call action, and the name of the server, the name of the action, and the body. This is the important part. Okay, I wanted to explain like a big case, which is how do we use it at Eventbrite, because it's a very lightweight library, but it's very powerful. At least we are serving a lot of traffic. Most of our services are PySOA. We use it as it's a general purpose. So we usually integrate it with Django because it gives us many tools to work with the settings, the DB connections, the ORM, login, for example. So all our systems are usually Django. So it's like a convention in our in the engineering team to use it with Django. We also orchestrate you use the whole HashiCorp suite, but especially for the services, we orchestrate with Nomad. So we have hundreds of allocations with PySOA services and different workers. And also it has more features, like, for example, instrumentalization. It doesn't have implementation with Datadog, but it has an abstract instrumentation layer, so you can customize and use whatever you want. You can use Datadog or Prometheus or other stuff. So to finish, I wanted to share some links for the reading if you're interested, and I'll happily answer all the questions you have. Thank you very much.
Just for one question.
Okay. As you can tell, I'm not an English native speaker. Feel free to do the questions in Spanish, and we can, if you don't feel comfortable with English.
Hey, thanks. How do you handle if a request in the server fails? So what happens with the client listening to that? How do you requeue the message or whatever?
Sorry, can you repeat? I'm sorry. What is it?
So if your request for paella, while doing the paella, that fails, I don't know, whatever, timeout or whatever, the message is already not in Redis. So the client listening to it will listen forever, or?
No, that's listen for. No, it will time out as well because it's the same mechanism. So the client will time out.
So there's no requeue or something.
No, you lose the message. It's very simple. Yeah.
Okay.
Just, you deliver one, but you don't know if you are going to get an answer. Yeah.
Cool. Thanks.
Okay. Thank you.
Okay. Thank you very much.